Our next video is a bit of an odd skill. We just talked about piecewise functions, and we saw that sometimes graphs of piecewise functions, or I guess the idea behind piecewise functions, is that the graph might follow one rule for a little while, and then at some point switches and starts following, they can't both be close, starts following a different rule. This is an example of what a graph of a piecewise function might look like. Well, if we think back to something we just learned about, the graph of an absolute value function, we know that at some point an absolute value graph, which is a straight line for a while, at some point it will just simply turn around and go the other way. And in a way, that is a piecewise function. It's following one rule for a little while, and then starts following another rule for the rest of the x values. Well, that's a piecewise function. So what we're going to talk about now is how to do that, how to turn the absolute value into a piecewise function. There we go. And so that's what we're going to do now. And so I have the steps written out, and I'm going to go through and kind of walk you through an example so you can see what I mean by these steps, because it is a bit of an odd skill, and it is a little bit tricky to get used to doing. So the first thing we're going to remember is that the idea of an absolute value function is that sometimes the absolute value function is just what it looks like without the absolute value bars. I call that the simple version. This is not at all a technical term, but it's just what I call it. But sometimes when the thing inside the absolute value is negative, then when we take it out of the absolute value, it becomes positive. It becomes its own opposite. So the absolute value of 3x plus 9 minus 10 sometimes will just be 3x plus 9 minus 10. But sometimes it'll involve the opposite of 3x plus 9. And so what I'm going to do is just write the opposite of 3x plus 9 minus 10. Really important to point out that the only part that gets negated, the only part that I take the opposite of, is the absolute value itself, this thing that was in here. That minus 10 stays a minus 10. So here we have our two function rules, 3x plus 9 minus 10 and negative 3x plus 9 minus 10. Of course, they both can be simplified. 3x plus 9 minus 10 is the same thing as 3x minus 1. So I might as well just call it that. And negative 3x plus 9 minus 10, I can simplify that too. First, I'll distribute the negative. And then I can combine those like terms. And it just looks a lot simpler and easier this way. So sometimes our function will follow the rule of 3x minus 1. Sometimes it'll follow the rule negative 3x minus 19. The only question is, when does it follow each rule? So remember, we call those the x values when we follow each rule, we call that the subdomain. That's the fancy word for this part of the piecewise function when we say when to follow each rule. So to find that subdomain for the simple version, we're just going to find out, well, when is that inside of the absolute value positive? Because as long as 3x plus 9 is positive, we're taking the absolute value of a positive number, which is itself. So as long as 3x plus 9 is positive, and notice how I'm switching to the color I'm using for my simple version right now. As long as 3x plus 9 is positive, or 0, which we can solve to figure out what this means. Subtract 9 from both sides, divide both sides by 3. As long as x is greater than or equal to negative 3, we will follow the simple basic rule where the 3x plus 9 stays positive, and in the end we end up with 3x minus 1. On the other hand, when will we follow the negated version, the opposite version? When would we have to take the opposite of 3x plus 9? Well, if 3x plus 9 is negative, then when we take its absolute value, we turn it into positive, which means we opposite it, we negate it. I know it's weird to say, use the word negate when we're making something positive, but that is what the word negate means. If something is negative, when you negate it, you're making it positive. So we will use the negated version whenever 3x plus 9 is less than 0. And it shouldn't surprise you when we finish solving this that we're just going to get the rest of the numbers. So 3x is less than negative 9, x is less than negative 3, which is everything other than x is greater than or equal to negative 3. You may find cases later on in the year when we have other types of functions and we kind of push them all together. The solving part here, this last thing, it might be a little bit more complicated than just, well, either x is greater than negative 3 or less than negative 3. But for now, like, it'll work out that way, where that negative 3, it'll be the cutoff. It'll be the cutoff on both sides. I will point out, by the way, that the or equal to, it very easily could have been here instead. Normally we say that can't happen in absolute value graphs, but remember that if x is negative 3, then 3x plus 9 is 0. We just discovered that. And there's no difference between positive 0 and negative 0, so it doesn't matter which rule we follow. That's why the or equal to is not very important in this case. So just to write the whole thing out as a final answer, f of x equals, remember it's a piecewise function, so I need to write my two possible versions. It is either equal to, I'm going to use this one first only because it's nice to put the subdomains in order. If you don't, it's not a problem. But the negated version, as long as x is less than negative 3. So the negated version, as long as x is less than negative 3. Sometimes it helps if you use the word if here, just so that you can see the difference between the function rule and the subdomain. If you don't use the word if, that's fine. And on the other hand, f of x would be equal to the simple version, without the negating anything, 3x minus 1, as long as x was bigger than or equal to negative 3. And so this would be our absolute value turned into piecewise. If you'd like to stick around and watch the next example, feel free. Otherwise, you can stop the video if you think you really have a handle on this. Okay. For the next one, it got a little bit trickier because there's another x in there. But that doesn't really change the process. We're still going to have a simple version, which is if 2x minus 5 is positive, then it just is itself. So it's 3x plus 2x minus 5 minus 11. And I'll simplify that. I can add my 3x plus 2x, and I can combine my negative 5 minus 11, and that's my simple version. If you want to figure out the subdomain rule for that now, you certainly can. I like to do simple version, negated version, and then come back and find their subdomains afterwards, but it's up to you to decide which you like better. For the negated version, again, be careful. Remember, the only thing that would be negated is if 2x minus 5 is negative, then its absolute value is its own opposite. The 3x isn't going to change. I don't care what x is. Like 3x, it's not in an absolute value, so it'll always just be 3 times whatever x is. But the 2x minus 5 would be negated. And so in order to simplify that, just make sure we're careful about distributing the negative first. So that becomes 3x minus 2x plus 5 before we combine like terms. And here we can do 3x minus 2x. And positive 5 minus 11 combines to negative 6. So we've got our two function rules. Now we just need to decide when do they each happen. And you can, if you want, you can, do it down here. I'm going to put it up here. And I'm going to say we'll do this whenever 2x minus 5. Remember, the simple version happens if 2x minus 5 is positive. Then we don't have to worry about its opposite. And add 5 divided by 2 as long as x is greater than or equal to 5/2. And we would use the negated version, the subdomain, the x values for which we would use the negated version is anytime the inside of that absolute value was negative, we would have to take its opposite. And so again, add 5 divided by 2, we'll get the same 5/2. So now for each situation, we have the function rule and its subdomain. Function rule and its subdomain, so we can put them all together to write our function. So f of x is, again, I'm going to put the negated one first only because it's the leftmost x values. The smallest x values go into the negated version. It's not always that way, but it is here. So we'll follow the rule x minus 6 as long as x is less than 5/2. And we'll follow the rule 5x minus 16 as long as x is bigger than or equal to 5/2. And that is the piecewise way of writing this absolute value function.